Students have many different ways of simplifying radicals. I will show you the factor tree method. If you know a different way or a faster way, by all means use it. You probably remember factor trees. If I start with 80, then I want to break 80 down into primes. So you can go any way you want, but I just want to think of numbers that multiply to 80. So let's start with 20 times 4. And then 20 can become 10 times 2. And once you get a prime, you can circle it. We're done with that. And then 10 can be 5 times 2. And then 4 is 2 times 2. And now we're all done with primes. And so I get 80 can be written as 2 times 2 times 2 times 2 times 5. And now what I want to do is I want to take the primes in pairs if I have them and write them in square roots. So here's a pair and there's a pair. So now 80 would be the same thing as the square root of 2 squared times the square root of 2 squared times the square root of 5. Right, here's your 2 times 2 and 2 times 2. And the reason I wrote that as 2 squared is because squares and square roots cancel each other out. So therefore, the square root of 2 squared would just be 2 times 2 times root 5 for a final answer of 4 root 5. All right, here's another problem. Simplify 125. So for 125, let's do the primes again. 5 times 25, and 25 is 5 times 5. And so 125 can be written as 5 times 5 times 5. So now the key is here that I want to write them as pairs because the squares and the square roots cancel, but the square roots won't cancel with, for example, 5 cubed. So I only have one pair of 5s, so I'm going to write this as the square root of 5 squared. Then I need another square root of 5. The square root of 5 squared, the square root and the square cancel and leave me 5. And then this other square root of 5, well, it's out of luck. It's just got to stay in the square root, and then that would be my final answer. In both those cases, you could test your answer by going to the calculator and typing both those in and seeing if they equaled the same amount.